Welcome to this comprehensive guide on Unity Netcode for game objects, designed specifically for beginners looking to dive into multiplayer game development. Unity Netcode for game objects is a powerful framework that simplifies the process of creating networked multiplayer games within the Unity engine. It handles the complexities of network communication, allowing developers to focus more on game logic rather than intricate networking protocols. This framework is built on top of Unity's Universal Transport Layer, offering flexibility with various network transports like UDP, TCP, or WebSockets. Understanding netcode is crucial for developing interactive multiplayer experiences, from cooperative games to competitive arenas. Let's begin by setting up our Unity project to integrate netcode for game objects. First, open your Unity project. If you don't have one, create a new 3D project in the Unity Hub. Next, navigate to Window, Package Manager in the Unity Editor. In the Package Manager, ensure Unity Registry is selected from the drop-down menu. Search for Netcode for game objects and click Install to add it to your project. This process might take a few moments, depending on your internet connection and system specifications. Once installed, you'll have access to all the necessary components for building networked gameplay. Now, let's explore the core components, the Network Manager and setting up a player prefab. The Network Manager is the central hub for all networking operations in your game. To create one, right-click in your hierarchy, select Create Empty, and name it Network Manager. Then, add the Network Manager component to this game object through the inspector. You'll also need to add a Network Manager HUD component for basic UI controls to start and stop the network. Next, we need a player prefab. Create a simple 3D cube or capsule, add a network object component, and drag it into your project window to make it a prefab. Crucially, assign this player prefab to the player prefab slot in your Network Manager component. This tells netcode what object to instantiate for each connected player. Now, let's delve into spawning networked objects beyond just the player. Any game object that needs to be synchronized across the network must have a network object component attached. To spawn an object, you typically instantiate its prefab and then call network object, spawn on its network object component. Only the server or host can spawn networked objects, ensuring authoritative control over game state. When an object is spawned, netcode automatically replicates it to all connected clients. Similarly, calling network object, despawn will remove the object from all clients. This method is essential for dynamic elements like projectiles, pickups, or enemies that appear and disappear during gameplay. Next, let's explore how to synchronize data and state across the network using network variables. Network variables are special variables that automatically synchronize their values from the server to all connected clients. Declare them within a network behavior script, which is a base class for network components. For example, a player's health or score can be a network variable, ensuring everyone sees the same value. You can subscribe to the onValueChanged event of a network variable to react to changes. This is useful for updating UI elements or triggering visual effects when a network value changes. Remember, only the server can directly modify the value of a network variable. Clients can request changes via remote procedure calls, which we'll cover next. Now, let's explore remote procedure calls, or RPCs, for client-server communication. RPCs allow you to call a method on a remote machine, either from a client to the server or from the server to clients. There are two main types: server RPC for client-to-server calls and client RPC for server-to-client calls. For example, a client might send a server RPC to the server to request shooting a projectile. The server then validates the request and, if valid, might call a client RPC on all clients to play a shooting animation. RPCs are crucial for actions that need to be initiated by clients but executed authoritatively by the server, or for server-driven events that affect all clients. Always remember to add the server RPC or client RPC attribute above your method declarations. Let's differentiate between client-server and host-client architectures. In a dedicated client-server model, there's a separate server machine that doesn't render the game, only handles game logic and networking. This offers high authority and security, as clients cannot directly influence the game state. In a host-client model, one of the players acts as the host, running both the client and the server logic simultaneously. This is simpler to set up for smaller games or peer-to-peer experiences, but the host connection quality affects everyone. Unity Netcode supports both architectures, allowing you to choose based on your game's needs. For beginners, starting with a host-client setup is often easier for testing and development. Let's cover some helpful tips and best practices for working with Unity Netcode. Always ensure your networked game objects have a network object component and are prefabs. Test frequently in a multi-client environment, even if it's just 2 instances on your local machine. Prioritize server authority for critical game logic to prevent cheating and maintain a consistent game state. Optimize network traffic by only synchronizing necessary data and using efficient data types. Consider using Network Transform for automatic synchronization of position, rotation, and scale, but be mindful of its performance impact. Leverage the Unity Netcode documentation and community forums for troubleshooting and advanced topics. Start simple, build foundational networking concepts, and gradually add complexity to your multiplayer game. Congratulations! You've taken your first steps into the exciting world of multiplayer game development with Unity Netcode for game objects. We've covered fundamental concepts, project setup, spawning objects, synchronizing state with network variables, and communicating with RPCs. Remember to practice these concepts and experiment with your own game ideas. The journey to becoming a multiplayer game developer is rewarding, and Unity Netcode provides a robust foundation. Thank you for watching, and happy networking!